This video is going to discuss the formula for sound pressure level. So if you have a bunch of different sounds in the room, what is the total pressure in the room from all of the sounds combined? It's kind of what we're asking here. And this is a logarithmic. It's not really an average, but if we explain the logarithm, it kind of makes sense what this formula does if you have a little experience with logarithms. So I'm going to first explain logarithm, the basic logarithm. I'm not going to go into all the properties because there isn't any kind of trick or property that you can use to solve this formula. Logarithm. So what a logarithm is, it's the opposite of an exponent. So in other words, if you have, say you have 3 squared is equal to 9. Okay. Well, log base 3, see, logarithms have different bases. This, without any number down here, it's base 10. So we're trying to figure out, if we add all these up, what is the exponent? That's what this is asking. So in this case, we're in log base 3. What is log base 3 of 9? So in other words, what this question is asking is, what exponent do you raise 3 to get 9? And that's 2. Okay, so in this question, without log, there's 2 basic logs. There's the natural log where the base is e, which e is approximately 2.71, Euler's famous number. And then there's a log without a number down there implies base 10. So in other words, log of 100 is going to be what? What power do you raise 10 to get 100? Or the other question could be, how many zeros are in there? 2. Log 1,000 is going to be what? 3. Okay. So these sources are divided by 10. Added up, it's 10 raised to this certain source. So we're trying to find out just how much power that each one of these individually are, by taking the log of all of them and trying to find a sort of average. And if source 1 is much bigger than source 2, source 1 is going to be influential on this when we take the logarithm out. For example, let's just say we have 2 sources, and this is going to be just to demonstrate the power of logarithms here. All right, so let's say one source was 5. If we did this, we got 4. I'm sorry, there's 4 zeros, and the other source only has 2 zeros. Well, this source is going to be much more influential than this one. So what we're finding here is the logarithm of 10100 when we add those 2 up, right? And what that's going to be is just a little bit over 4. So like 4 point, let's see what that is. We're going to go over to the calculator real quick so we can demonstrate how to find logs. Okay, this is just regular. I got on Google Chrome and typed in calculator. And we want to find out what the log of 10100 is. And you can see that it's that second input barely affects the total power on the first input. But that's not using the formula. Let's use the formula and use this example here. So let me go back to my camera. Okay, so in the original formula, we wanted to find the total sound pressure level with 3 sources. So we're going to take 10 times the logarithm. The first source, and I'm going to try to write this real big because it's a little trick, you know, these exponents can get real small, so I'm going to write as big as I can. The first source was 89 decibels. 89 decibels, and we divide that by 10 because when we find this mean, we're going to multiply it back by 10 out here. And it's not a mean. I say it's a mean, but it's not. The second decibel level is 87 divided by 10. And the third source is 78 decibels divided by 10. Okay. So this is the strongest power level of decibels in the room of the three sources. So these two are not going to have that much effect. It's going to add to it a little bit, okay? But if you just do the inverse log of this, 10 log of just that, you get 89, okay? Because log is the inverse of this. Log of this, log of 10 to the this is 8.9. Then you multiply it by 10 again and you get 8.9. The hard part about this is you need to add these up. You need a calculator big enough to add these up. So we're going to add each of these individually. Now, let me go back over to the calculator here. Yep, I'm there. Okay. I'm going to clear everything out. All clear. Okay. So, oh, clear. All right, so we're going to take 10. We're going to do what's in parentheses first. 10. And then I make it an exponent. I'm going to go ahead and do it in decimal form. 8. Okay, so that's the 10 to the 8.9. So we're going to take 10 to the 8.9 plus 10 to the 8.7 plus 10 to the 7.8. Okay, so we're going to find this sum here. We're going to hit enter. And then we're going to take the logarithm of it, and this number is going to turn out to be log of answer. There we go. 9.13, and then we multiply that by 10, which part of the formula says to do, and we get 91.33. So of the three sources, so there was three sources in the room. 3 sources in the room, 89 decibels, 87 decibels, and 78 decibels. Added together, the total sound pressure level is approximately, and I have to put approximately because these never, it never stops. These decimals, it's all irrational, is approximately 91.33 decibels. Okay, that's the total pressure level in the room.